Domain Modeling Made Functional with Scott Wlaschin.
The Azure DevOps podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. This podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient, able to deliver world-class results. They are hiring architects and .NET engineers who'd like a path to become an architect. So you can check that out on clearmeasure.com/careers. I have with me, our guest today is Scott Wlaschin, and he is an expert on F#. He's also the author of the popular F# site, F#forfunandprofit.com. We'll include the link in the show notes, and a board member of the F# Software Foundation. He's known for his non-academic approach to functional programming and is a popular speaker and has given talks at the Norwegian developer conferences, NDC, F# Exchange, DDD Europe, and many other conferences around the world. Scott, how are you, sir? Welcome to the show.
Thanks for having me on. It's great to be here.
Oh, my pleasure. My pleasure. Before we kind of get into, we have a lot to talk about. Not only your book, but recent conference talks and things you've been working on. But for those listeners who maybe haven't seen you before in the public setting and are just getting to know you for the first time, it's always interesting to ask, what are the high points in your career that's kind of led you up to what you're working on today?
That's an interesting question. I don't think I've had a kind of linear career. I've kind of jumped around a bit because I've been around a long time. And actually, for people who don't know, I'm pretty old. Like when I was young, the world was in black and white. That's kind of how old I was. So, I started off, I used to do a lot of database programming when I was doing, kind of enterprise, small business database programming. And then I got into Smalltalk, and I did a lot of object-oriented programming, and I was in various startups for Smalltalk and stuff. And then I got into C# and .NET when it came out, which is like 20 years ago now. And then I was doing C# for a while, and now I'm doing F#. I got into F# about 10 years ago. And so I've alternated, I've done a lot of database stuff. I've done startups. I've done big government enterprises. I've done super duper OO stuff with Smalltalk, and then, functional stuff with F#. So I've just done a lot of different things. To be honest, I actually kind of, after a while, you kind of get bored of something, and it's like, I want a new challenge. And that's one of the reasons actually that I actually started learning functional programming, because I was sort of, felt like I really knew everything there was to know about OO and databases and all that stuff. I thought, well, I wanted, something different. And so that's how I got into functional programming. So, and that's pretty much what I'm doing right now as well. I've been doing that for 10 years now.
Okay. Yeah. I don't remember the exact year that F# came out, but it's been over 10 years. Can you refresh on the history on that?
It was originally a research project done by, it actually came out of Microsoft Research, not Microsoft proper. And the main person in charge of kind of productizing it was Don Syme, who's a researcher at Microsoft. And he's actually now, I think he's working as part of GitHub research, but it's, on the more research side of things. And F# is a family of languages called ML languages, and standard ML, and OCaml is another one. And there's various languages. The Elm is sort of in the same family, and they're basically functional languages which are very easy to use, very friendly functional languages. They're not kind of weird. And so they wanted to do a kind of a functional language on .NET, because at the same time, that was the same time they had like Iron, Python. They had their dynamic languages on .NET with Iron, Python, Iron, Ruby, and so, well, let's do a functional language on .NET. So they picked a kind of ML language, and they converted. Don and his team did an absolutely fantastic job of making it fit in, because .NET is a very OO framework, and they managed to make it fit in really nicely. It fits in. It's got fantastic tool support. It was first shipped as part. It was available in 2005, but it was actually shipped in 2010 with Visual Studio. So it actually was, it actually shipped as part of Visual Studio in 2010. Pretty much April 2010. So it's pretty much 22 years ago exactly that it was, 12 years ago exactly it was shipped. So, and that's pretty much when I first started paying attention to it. It's like, I don't even have to install anything. I could literally just open up Visual Studio, which I already knew really well. And it's like, oh, let's try out this new language. It was really hard. I have to tell you, it's like, oh my God. I thought, because I knew lots of languages. I've done C# and Python and, JavaScript and Java and, lots of language, but functional programming really hurts your brain when you're not used to it. So I thought it would be easy to learn, and it just took me a while to get my head around it. And that's one of the reasons why I started my website, F# for Fun and Profit, because I thought, let me blog about what I'm learning as I learn about it. Which, by the way, any developers, I highly recommend doing exactly the same thing, because when you write things down, it forces you to explain things to people and it forces you to learn things. So yeah, I started my website, and that website turned out to be really popular, surprisingly popular. And and then I started doing talks, and I wrote a book, and there you go. That's where I end up.
So here in 2022, what types of applications should developers be looking at F# for? Like the R language is talked about in machine learning and artificial intelligence, but and C# of course, general purpose. Oh, you can build any kind of business application, but is F# truly general purpose like that, or does it really fit in a niche better?
No, absolutely. Anything C# can do, F# can do. So the reason you'd pick one over the other is to do with your programming style. Just like Visual Basic can also do anything. I mean, they compile down to the same thing. So all the features that C# has, I mean, that's what I'm saying. F# has a lot of OO features in it explicitly to make interop with C# and the .NET libraries really easy. And because of that, you can, like a lot of languages which are standalone languages, the libraries, they might be great languages, but if you want to interact with Azure, or you interact with, a well-known API, they don't have a .NET, SDK for that. But in F# you can just pick up any old SDK, which is a .NET friendly SDK, and you can just plug it right in and start programming straight away. So, and F# supports all the stuff that C# has had recently, like the zero allocation stuff, like spans and all that stuff, and structs and all that stuff. F# has those as well. So you can do high performance stuff in F# just like you can in C#. You can do database. Anything you can do in terms of database access, you can do that in F#. So there's literally, it's not anything. It's not a language that's only reserved for special things. And it's a general purpose language, just like C#. So it really depends on how you like to program. If you like to program in a functional style and you want to be on .NET then F# is perfect. And if you like to program in an OO style, then, C# is perfect. So,
So people can adopt it in maybe even just one of the projects in their Visual Studio solution.
Exactly, and you can mix and match. So it's very common actually to have C# projects and F# projects mixed in the same solution, because, for example, F# for domain modeling, for the core domain, I personally prefer F#. It's really excellent for domain modeling, and we can probably talk about that shortly. And there's some things where C# like Razor, it's very C# friendly. So if I'm doing maybe web views or something, if I'm doing that kind of thing, I might use C# for that, and XAML kind of stuff, maybe C#. But there is F# support for that. But if you're used to doing that in C#, you might just stay with that in C# for the UI side of things, but use the core domain in F#. So yeah, you can totally mix and match because they all compile to .NET DLL. So
sure. So your book, Domain Modeling Made Functional, is published in 2018, but domain-driven design, and I guess the common term domain model and its popularity, the book by Eric Evans back in, I think, 2004, was it written? The turquoise book or the light blue book?
Yeah, that's about 20 years old. Yeah.
Right. So just what was the motivation when you said, you know what, this book needs to exist, and I guess I'm going to write it?
Well, what happened was when I first got into functional programming, a lot of the functional programmers were very kind of mathematical oriented. And that's, I think, why functional programming kind of got this reputation as being kind of academic and lots of jargon and stuff. And I've always been like kind of a traditional enterprise programmer. I mean, just kind of CRUD kind of programs. I'm not really into the weird mathematical stuff. I mean, I sort of understand that, but that's not why I do it. And I found out that the functional programming is actually really, really good for doing domain-driven design. And I noticed that other people had not really talked about that very much. I mean, as somebody, because I think the domain-driven design people traditionally were OO based, and the functional people were more academic, and there wasn't a lot of crossover between the two. And as someone who'd come through the OO, who was there at the beginning, like a lot of the OO stuff was from Smalltalk people. Like, all the Kent Beck was a Smalltalk programmer, Martin Fowler was a Smalltalk programmer. So when I was doing Smalltalk, I was in the middle of all that stuff. So when I started doing functional programming, it's like, how can I apply the same stuff to functional programming? And so I started doing domain-driven design. It's like, this is great. And so I started doing some talks about it. And then, I was invited to do a book. Pragmatic Press called me up and said, would you like to do a book? And it's like, yeah, great. So I did a book, and people seem to like the book. And I was just trying to prove that, you can do domain-driven design in any language, in any style. But I actually really do think that I can explain, if you want, why I think that functional programming is actually better for domain-driven design.
Please, yes. The listeners want to know.
Because a lot of people, like I say, traditionally you think of domain-driven design as an OO thing. So the first thing is domain-driven design. It has nothing to do with a particular language. It's a process, just like Agile. Right? Agile is not a language. Agile is a development process, and so is domain-driven design. It's like focus on the domain. Don't focus on the technology. Focus on what are you actually trying to build? Why are you trying to build it? Can you capture what you're trying to build in the code in such a way that there's a minimal kind of translation between how the words that people use when they talk about it in the real world and the words that you use in the code? So ideally, the code should be using exactly the same words that you use in the domain and in the vocabulary that people normally talk about. So that means not using words that are weird developer words like, a proxy factory, abstract bean, proxy factory, all that kind of stuff. That's not a domain. Those things don't exist in the real world, So it turns out that in F# has a type system, which is called an algebraic type system. And I prefer to call it a composable type system because you build bigger things from smaller things like Legos. And one of the ways you can actually build things by adding things together, like I say, I want a first name and a last name and an email address. So that's a very standard thing, like a typical, any kind of record or a struct or a simple class can represent that. But the other thing which is really common in domain modeling is to say something or something. So I want an email address or I want a phone number, or it's red or yellow. And those things are really hard to do in most OO languages, surprisingly. You can have enums, which is fine, except that you can't have any extra data associated. Like an email, let's say I'm paying by cash or I'm paying by PayPal. Well, in the PayPal, if I'm paying by PayPal, I need the email address that you're paying with. Right. And if I'm paying by credit card, I need the card number and the date and all that stuff. So what you want to do is attach extra data to each of those choices. And you can't really do that with an enum. The nearest equivalent in OO would be to have subclasses, right? Each subclass you inherit from sort of base class or an interface, and each subclass has the extra data that subclass needs to know what it's doing. But in C#, that if you have 4 subclasses, typically that's 4 files, 4 separate files.
It gets clunky.
And in F#, that's 4 lines, 4 lines of code as opposed to 4 separate files. So you can do this. I mean, it's theoretically they're the same thing, but from a practical point of view, having 4 lines of code that is just very explicit, that this or this or this or this, and it's just all right together on one page, makes it a lot easier to show to other people and get, if you're doing code reviews or you're getting feedback from non programmers. One of the things with domain modeling is you're trying to get feedback from people who aren't programmers so they can say, actually, you forgot this thing, or can you do this other thing? If you can actually show them real code and they can actually give you feedback on that real code, that's fantastic. And that's something you can actually do in F# really well. And this kind of a little bit harder to do in C# because it's there a little bit, all the curly braces, and it's just, it's not quite so friendly for non-programmers, I think.
Oh, for sure. And speaking of real code, you have the full source code of a application that you built for the book on the website that the listeners can download.
Yeah, so that's, I think, one of the things that people like about my book is I take the same application all the way through from the beginning to end, rather than kind of chopping and changing. So it was the first part of the book was it talked about the conceptual, just documenting the model through talking to people, and then you build a domain model, and then you build a full implementation with the database and all that stuff. So yeah, that is what I have. I have the code basically because I don't want people. If you're writing a book, yeah, you could type out all the code in the book, but it's like easy just to download the code.
Oh, for sure.
So it's a full application that you can play with, and I'm a great believer in sharing code examples and having other people read your code. It's a great way to learn. It's fantastic. Looking at other people's code is a great way to learn how to do things.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Just a side tangent on that as an industry, whether it be literature or art, there's so much to be gained by observing and reading prior works of others. And yeah, so any opportunity we get in this industry to observe or read the prior works of others is hugely beneficial.
It is interesting. I mean, I've been around, I was around at the beginning of at the beginning of the web, right? I mean, I remember the first web browsers coming out. And one of the things about the early days of the web is that everything was completely transparent. I mean, all the all the HTML source code, you just say view source and you can see.
That's right, because that's all there was.
That's all there was. And and when people started putting JavaScript in, you could see all the JavaScript. And nowadays, if I look on view source, of Facebook or Gmail or something, it's like
they obfuscate the JavaScript even
and
for
they
those
obfuscate
spots.
Exactly. Yeah. So I can't really learn anything. I mean, it's really hard to learn from those. For most modern websites now, they're not set up to be easy for people to understand. Right. But the original websites were, I mean, people hand typed them into Notepad, and there was something to be said for that. There was a certain charm to that, and it was a very do-it-yourself. It was a very do-it-yourself thing. I think a lot of people, I mean, back in the day, anyone can create a website. You just open up Notepad, start typing, and upload it. And then
they still can, but they just don't want to anymore.
No, well, it's hard though because you have to. It's just not. Yeah, I mean, you still can, but people feel that it's. I think a lot of people feel it's out of their reach, which is sad because I do think it is, as you say, it is within their reach. But if you look on a book on web development, they're not going to say open up Notepad and start typing. They're going to say download,
WordPress,
or they're going to say install npm and install this SPA framework, install React and install this and then you do these dependencies and you have to use this and this and this. It's like I just want to write a single web page. Do I really need all this other stuff as well?
Well, we're going to include a link to your book, Domain Modeling Made Functional, and I'd recommend any of the listeners go and check that out. But you've done a lot of conference talks as well, and you have an interesting take on how the functional thinking impacts architecture as well.
I do, and so yes. So I mean, like I say, I think you coined onion architecture, and I'm a great fan of onion architecture.
Back in
and
09, I think.
But yeah, and that's the word when I'm talking about functional architecture. I talk about using onion architecture in a functional way. So one of the things about functional programming is you want everything to be deterministic. Like in a true functional programming, nothing can change. You can't even write to the disk. But obviously that's in most languages that's not really practical. But what you can do is try and separate out the kind of deterministic codes from the non-deterministic code. So the code, deterministic, like adding two numbers, when you add two integers, you don't expect them to change underneath you, right? It'd be really hard to work with. So we try and write all our code that way. So, for example, we very rarely would like update a record. Let's say we're modifying the name of a customer. We wouldn't actually have a mutable customer that we change the name. We would pass in a customer to a function, and we'd spit out a new version of that customer as the output. So the input is not changed, which is making a clone of it and modifying the clone, and which means that it makes, first of all, if you write your code in this way, and when I first started functional programming, I thought, well, how can you write any applications without mutating, without having mutable variables and all this stuff? And I thought that was impossible. Well, it turns out actually it's not impossible. And actually, once you get the hang of it, it's actually pretty awesome. As functional programs, we try to write as much of the code as possible in this way, where you basically do not mutate anything. And this is once you get the hang of this, it has so many advantages. So the first thing is that unit tests become really easy because everything is completely predictable. You pass in this, you get this out. And so unit tests are, basically you never have any kind of I/O in your codes because I/O is a huge source of unpredictability. Mm-hmm. And so, if you write or read to a database or file system or network or something, you don't really know what's going to happen. And so we try and eliminate that from our domain model. So, fits in really well with domain-driven design, which also says don't have any database stuff in your domain model. So if you don't have it in your domain model, where do you have it? Well, you have it on the outside. So you have your core domain model, which is pure code, completely deterministic code. And then anything to do with databases or files or whatever, that is around the edges. So a typical functional program would say, okay, read something from the database, process all the stuff, do all the business logic, do the decision making, and then the output of the function is, what should I do? Should I save this record? Should I update this record? Should I delete whatever? That will be out, and that's where a choice type is really useful because you could have a choice as one of your outputs. It's like, do I do this, or this, or this? And then on the outside of this, then you say, okay, well, they wanted me to delete the record, so I'm going to. Then they have the SQL code that actually deletes the record, And the same thing with, if you've got a website, the input is a JSON. It's a web request. I mean, websites are basically functions. There's an input, which is a web request, and the output is a web response or an HTTP response. And, the input, you parse the JSON, parse the query parameters, then you do your business logic, and then the output is like, well, is it a success? Is it a failure? If it's a failure, you return a 500 or a 400. If it's a success, you return a 200 and with the JSON body or whatever. And so you naturally fall into the onion architecture because all your core domain is in the middle, and all your your interfaces, as it were, in the middle, and your implementations, the actual stuff that does the I/O, is on the outside, and it's a match made in heaven. So yeah, if you follow the functional principles, you end up with something very much like onion architecture, just without even trying.
So it sounds like your core project, that's going to be your domain model, but then your abstract implementations that have to interact with other libraries, other dependencies, is that just adapter code, transaction scripts?
Yeah. I mean, you can, at that point, you can do anything like. So I typically don't use anything like Entity Framework because I don't have my database in the middle of my domain. So I would actually use something like Dapper and something very simple to read some SQL or whatever it is. So I use Dapper to read some SQL, and I translate that into a domain model, and I pass that domain model into my workflow or my process that handles it, and then I spit out another thing at the back end, and that gets saved back to the database or turned into JSON or whatever it is that you're going to do. So it turns out you don't need Entity Framework is a very object-oriented framework, and it's not necessary. And so you actually tend not to use interfaces so much, because in the OO model, you pass in an interface. Like because it's a behavior-based thing, it's like I want an object to save itself, so I will pass it an interface which allows it to save itself. I will pass in a repository interface or a database interface or something, and the object will save itself using that interface. In functional programming, we wouldn't write it that way. We'd just say, you have a function where you pass in something and something comes out the other end, and then you connect. So it's much more like the other analogy I like to use is the pipeline model, which is like straight out of Unix pipelines, where you take the output of one thing and you feed it into the beginning of the next one. You take the output of that one, you feed it into the next one. So the pipeline model is again pretty standard in functional programming. And so the beginning of the pipeline is where you read something from the database, or you deserialize your JSON or whatever, and then you pass it through a series of pipes. In each pipe does one little thing, and then at the output you get an order, and then again the last thing in the pipeline is the saving it to the database or whatever. So another way, it's actually, if you're used to web development, it's very much like middleware, right? In the middleware, you have all these different things which you hook into, and each one has the input and the output that it passes through to the next one in the chain. So basically, functional programming is like writing your entire app like middleware. So every single piece is designed to fit with the previous one. The previous piece does something, it passes the next one, it does something, it passes the next one, it does something.
Now, is each piece aware of whatever the next piece is, or is there other code on top that is the orchestrator that gets it back and then passes it on?
Exactly. The second one, there's a kind of glue. Each individual piece does one thing well, and then there's a kind of a piece at the very top which assembles all these pieces into a single pipeline and adds the dependencies or whatever it is. And so what would be in OO application, what you might call the composition root, where you connect all these things together, you'd have a similar kind of thing in a functional program where you connect all the different components together into a single pipeline. And what's nice about this, and is, just to harp on about architecture, is that this actually goes all the way back to what Matt and Fowler call the transaction script model. So the transaction script model was where you just basically wrote a script for doing one thing, like classic kind of COBOL.
Procedural, structured programming.
Very procedural. You read some data, you do something, and you spit out the data. And then if you want to process the data in a different way, you write another script to process it in a different way. And the problem with that, that is really very unfashionable, because there's no reuse between the scripts. You basically copy and paste the whole script and edit it, which I have done.
Yeah.
And then, and you don't have a domain model. Basically everything is slightly different. But the fantastic advantage of transaction scripts is that each one is decoupled from all the other ones. One of the problems with OO design is often you get these very, very coupled things where, in order to do one thing, you have to bring in this object which does this other thing, which brings in this other object which does this other thing. So, for example, let's say that I have a customer and I want to update the customer's name, and I want to delete the customer, and I want to change the customer's password. I might well put that all on the same interface because I'm lazy, because I think it's all customer-related stuff. But the problem is, from a domain modeling point of view, the process for changing a password is actually completely different from the process from changing a name.
Right.
Because there might be extra authentication involved, or there might be extra stuff. They're different processes. And so they really, really, just because they have customers in common doesn't mean they really should be on the same interface. So, the transaction thing would say, well, these are completely separate processes. I'm going to just write them separately. And that way, if I change one, I'm not going to break the other one. And it's easy in OO stuff to accidentally break. You change one thing and you accidentally break something else because they're all they're all coupled together. And that's, there are rules, there are things like this, the interface segregation principle. There's things to help you avoid that. But you have to try. It's always a battle to avoid that. And the nice thing about functional programming is you avoid that without even trying, because you just can't even do that. It's like the thing in the OO equivalent would be where every interface has one method. Right? If you had that kind of a design, you literally couldn't contaminate interfaces, because they literally can only ever have one method. So, that would be kind of weird. In OO world, that would be a very weird way of working. But in the functional world, that's sort of the standard way of working. Yeah.
So with C#, there is what appears to be some growing popularity in adopting just a functional view, and CQRS or CQS, whichever, either way, commands and queries, and they all do one thing. You might have 10 different things that have to modify something in a customer record in a database, but they're all independent classes. Do you see that implemented in the F# world at all?
Yeah, I mean, again, that falls out naturally because you don't really focus on objects in functional programming. The main thing is the function and not the object. So the data is flowing through these functions, and so it's quite common to write separate data structures specifically for a particular story or particular workflow, a use case. You don't feel like you have to reuse these data structures for every possible situation, because they're kind of disposable, really. And so, I mean, the command query separation is really good, because it turns out the kind of data you need to do an update is not the same kind of data you need when you read, and so they should be separate data structures. And in OO, it's kind of easy to have them merged together by mistake. And so the CQS is just like, try and keep them separate. Well, again, in functional programming, that would never happen, because you're not kind of attached to data structures as a key thing that you have to reuse the same data structure in every possible situation.
Right. It would seem to me that in this style in F#, the method sizes would be quite small and the file sizes would be quite small. Is that true?
Yes. And well, so in F# you don't organize your code by classes. You just basically, all the functions and the data structures that are relevant to one particular use case, you would put them in the same file. And then if you have another story or another use case, you put all those ones in a different file. And if you have data structures which are shared, like a domain model, which is shared across all of them, then that would be in another file, and that file would be shared, between the other ones. So if it's specific to a particular story, you would have it right next to the code that uses it, and if it's more generic, it's a more reusable data structure, then you'd have it, in some shared file. So the way that you organize code is very different than in an OO model. Absolutely
fascinating. Well, we could fill up 10 more episodes on this. A lot of information for people who are listening to this and they're just intrigued. Along with grabbing your book, is there any other resources or places where you would direct them to quickly learn more?
Yes. Well, I mean, if you don't want to get my book, I have a talk, a conference talk, which is what the book is sort of based on. So it's a 60-minute talk, and we'll put a link in the show notes for that. And I have a bunch of, you search for my name on YouTube, you'll find a lot of my talks, which is probably the best way to kind of get started. And then there's my website, F# for Fun and Profits. And I also have a reading list, which I like to share with people, which is the books that have influenced me as a developer. And the reason I like to share it is because most of the books are not about software. They're actually about non-software topics, like, design, the design of everyday things, for example, Don't Make Me Think, and books on architecture, like How Buildings Learn by Stuart Brand, those kinds of books, So I think those are really, if you're planning to kind of expand your horizons as a developer, in addition to development focused books, it's really good to look at other stuff as well.
Absolutely. We'll make sure to include all those in the show notes. Well, Scott, thank you so much for coming on the show and spending some time with us. This is fascinating for me, and I'm sure for the listeners as well.
Yeah, thanks for having me on. It's been great.
Oh, my pleasure. My pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.